Hi, we're Group 11, and our project is about renewable production and consumption. So for our project, we had three kind of guiding questions for it. The first is, where is renewable energy being produced currently in the US? The second, where is energy demand the highest right now? And third, where is the potential for future production the highest? So looking at the imbalance between current renewable production for electricity and energy demand. We kind of thought that it was likely that with wind energy being produced mostly in the Midwest, but there probably is not a ton of demand in the Midwest. And then comparing that to solar production and where energy demand is the highest. So for our data, we took it mostly from two sources. First, the EIA, which is the US Energy Information Administration. That's where we got all of our consumption data. And then the other site was the National Renewable Energy Laboratory, which is where we got all of our wind energy and solar energy production potential. It was both vector and raster data. And so using that data, we were able to produce kernel density maps to show current production as well as demand.
So obviously we wanted to look at where future renewable energy could be expanded, but we first wanted to get an idea of what the current energy demand is in different parts of our country. So I found a tabular data set from the U.S. Energy Information Administration for the sales to ultimate consumers of energy in 2019. And ultimate consumers essentially means like it's sales to people that are just going to use the data. It's not resold somewhere else. So it's just basically consumption data. And so I took that data. It wasn't geo-referenced or it wasn't spatial data. So I joined it to a layer with the US states and produced this this map here. And so the areas in darker red are where there is a higher demand for energy consumption. So clearly you've got California, Texas, and Florida as the big three. And it makes sense because they have the highest populations. And then in the Midwest, there's not much going on there. And on the East Coast, you get more in the middle range to upper range. Obviously I would have liked to get some like a data set that would allow me to see more closely, more precisely where the consumption would be, like in the counties or tracts of different states. But that was a little tough to find. And then it would have been cool to try and pair that with the current power grid to see where energy demand is versus where the grid layout is. But another interesting thing to note is while some states definitely consume more energy than others, some states actually produce more energy than they consume. An example of this is like Alabama, which produces more energy through all sorts of means, not just fossil fuels or renewable, but both, than they consume. And they'll actually use that electricity and send it to other states that consume more than they produce, like the neighboring state of Georgia is a good example of that. And so it's not an efficient process because you do lose electricity over transmission, but that is something that is in place. So areas where there could be a high potential for renewable energy could share electricity with neighboring states.
As of 2020, the US produces an average of 338 terawatts of wind-generated electricity over a year, coming from about 60,000 functioning wind turbines. As shown in this kernel density map, many of these turbines are primarily located in the central United States, roughly coinciding with the geographic area known as Tornado Alley. This area of the country has significantly higher wind speeds than the national average, with many central states having an average annual wind speed of around 9 meters per second, and the rest of the US having an average of about 6 meters per second. This creates higher potential for wind-powered energy in the Plains region. The areas of greatest potential are displayed in this raster map. Specific potential is due to the geography of the central United States. This geography lacks trees and hilly terrain that many other parts of the US have, which provide friction for wind currents, which are caused by air pressure differences. 3 out of the 5 of the biggest wind farms in the United States are all located in Texas, which is shown to have high potential for wind-powered energy. And these farms have combined capacities of a range of 400 to 700 megawatts per farm. These farms contribute just a fraction of Texas's massive power demand, one of the greatest among all US states. Large areas of the central United States, however, predominantly the less populated areas, show a large discrepancy between the amount of potential for wind energy based on geographic data and the actual existence of any wind power production due to the decreased demand in those areas. States such as Wyoming, Montana, and Nebraska have some of the lowest population densities in the US, yet some of the highest average wind speed. A potential solution could be found in developing transmission line technology to minimize power loss along large distances from these states to more populated areas. Some of the greatest untapped potential in wind energy lies offshore. The National Renewable Energy Lab estimates that the capacity for offshore generation is as high as 7,200 terawatt hours per year, about 20 times greater than the current generation onshore. While the US has made progress in developing a total of 2 fully operating offshore wind farms with a total capacity of 42 megawatts, other countries such as the UK are drastically ahead with an offshore production capacity of 10,400 megawatts in 2020. While onshore production has the most potential concentrated in the plains, offshore production would provide power to the states without access to those power sources, specifically the coast, creating a more balanced distribution of energy to the US. Wind along the shores of the northeast and northwest coast show average speeds of over 10 meters per second in some areas, exceeding the wind energy potential accessible on land. The offshore industry in the US is slowly growing. As of 2021, 12 more wind farms are under development in the US, with promise to operate in the next 5 years and help contribute to the future of renewable energy. Additionally, wind power promises a unique potential over other sources in the near future due to increasing wind speeds. In the last decade alone, average global wind speeds have increased from 7 to 7.4 miles per hour due to natural climate change cycles. Estimations show that by 2024, wind-generated power could increase by 37%.
This kernel density map highlights that the Southwest United States currently dominates solar power production. California in specific is the top generator of solar power in the country. It produces 33% of the country's solar power at 2,855 megawatt hours. This country was ahead of other states in terms of utilizing solar power as renewable energy. California produces so much solar power that there's an excess that the state pays nearby states, such as Arizona, to use. Furthermore, an energy battle between natural gas and solar power is occurring in California, which is why there is so much excess solar power to sell. On the eastern coast of the United States, Massachusetts and North Carolina are also big generators of solar power in the top 10 of solar power generators per state. Both states have tax credits for home buyers to use solar panels on their houses, as introduced in 2017. Furthermore, these tax credits are also applicable to commercial buildings as well. The center of the United States does not utilize solar power as much on the coast because these states rely on fossil fuels or wind as their sources of energy. Next slide, please. The potential energy map is similar to the current usage map. The center states of the country have lower solar energy potentials than the coasts. This also follows the current usage trend that the Southwest United States is the best location and has the most potential for solar powered generation. These states have the most hours of sunlight and direct angles from the sun for solar power generation. Other southern states, such as Alabama and Mississippi, have solar potential that is currently not being used due to natural gas usage for energy.
So as you can see, both solar and wind are used all over the country for energy production, but wind tends to be in areas with a lot less demand because of the nature of where wind is produced. So in kind of conclusion, we found that using all three, both onshore, offshore, wind, and solar, as a potential solution for converting the US grid to an entirely renewable energy production would be the best application. You can use wind all throughout the Midwest, but you'd have to use larger transmission lines. But offshore wind is also a great option due to the fact that most energy consumption is on the coasts, all the way from Florida to Massachusetts and California, all the way up through Washington State. So using this information, we can better build a grid in the US that can optimize both production of energy and balancing that with where consumption is as well.